In this lesson, we will be going over our third main trig function, tangent. In our last lesson, we talked about two of our basic trig functions, sine and cosine. We discussed how we can think of them as percentages, leading us to use ratios for their calculations using an archery example. Let's stick with archery to continue our discussion. In our last video, we saw that as we increase the angle we hold our bow, going from 0 degrees to 90 degrees, an arc is formed from our values of sine and cosine. Let's say there's a target straight across from our arrow, no matter what angle we hold our bow at. Our arc is now lined with targets. For our arrow to get to that point, it had to move up and over, which is where our sine and cosine came in. But now let's take those targets away. How is the arrow getting down? For the purposes of this lesson, we will ignore the fact that arrows follow more of a curve. Instead, we'll say that in this universe we've created, we need the arrow to turn downwards in such a way that the line the arrow followed to ascend or rise is perpendicular to the line the arrow must follow to descend or fall. In other words, these two lines need to form a 90-degree angle. By doing this, we ensure that the arrow only touches the arc at one point, and that is the point where our target used to be. So how far does our arrow need to travel to hit the ground again? Well, to hit the ground, our arrow must move some distance over and some distance down. Since we are concerned with both a change in height and movement outwards, just as we were with sine and cosine respectively, we use both of these functions to make our calculation. Tangent is equal to the sine of the angle divided by the cosine. But do we really want to make the sine and cosine calculations first if we don't need to? It seems a bit unnecessary if we're only asked to find the tangent. So let's rearrange this formula a little bit. We know that with trig functions, our names can get pretty long, so we don't always want to write out the full name every single time. So for tangent, we can abbreviate this using TAN, and then in parentheses, we have whatever is going to represent our angle. In this case, we'll call it X. From our last video, we know that sine is represented as SIN with our angle in parentheses, and cosine is represented as COS with our angle in parentheses. We also know from our last video that sine is equal to the opposite side over the hypotenuse. And we're just going to abbreviate here so we don't have to keep writing out all these words over and over again. We also know that cosine is equal to the adjacent side divided by the hypotenuse. So just by using some basic algebra, we can rearrange this to get a simpler tangent function. So we have opposite divided by hypotenuse times hypotenuse divided by adjacent. The hypotenuse cancels out. So we're just left with tangent is equal to the opposite over the adjacent. Just like when we changed our angle with sine and cosine, there is a trend that tangent follows. As our angle gets closer to 0, the arrow will have less of a distance to travel, and our tangent will eventually reach 0. As our angle gets closer to 90 degrees, our arrow has farther to travel. In fact, as we reach the top of our arc, the distance the arrow needs to travel to reach the ground becomes infinitely large. Notice that if we are at the top of our arc, to form a perpendicular angle, we would draw a completely horizontal line. No matter how far our arrow travels, it will never reach the ground because it is traveling in a line that is parallel to it. In this case, we say our tangent is undefined. This visualization will be useful for a later lesson where we will introduce the graphs of these trigonometry functions. Now let's do a quick example. Find the tangent of angle A and angle B. So if we wanted the tangent of angle A, this is equal to the opposite side, which in this case is 4, divided by the adjacent side, which in this case is 3. So just doing the same process for angle B, tangent of angle B is equal to the opposite side, which is 3, divided by the adjacent side, which is 4. You've now learned the basics of 3 main trig functions, which has now opened the door to so many possibilities. In future videos, we will go more in depth with trigonometry, and thanks to this great foundation we've built, we'll have a much easier time understanding where everything comes from. If you thought this lesson was helpful, make sure you like this video and subscribe to stay up to date on our latest content.